So in this video, we're going to talk about sequences, and we're going to talk about two different types. So the first one that we're going to talk about is arithmetic sequences. So arithmetic sequences, basically what they are, you're basically adding up, or there's a common difference between each individual term. So for example, let's say you had like 3, 5, 7, then 9, and continues. So you can see that in this particular problem, you have a common difference. If I were to subtract 5 minus 3, you're going to see a 2. Then how do I get from 5 to 7? I'm going to add a 2. Then how do I get from 7 to 9? I'm going to add a 2. So you can see that there's a common number that's being added or subtracted from each other. Okay? So in this case, this particular sequence is what we would call arithmetic. So we call it an arithmetic sequence because there's a common difference between these values. So it's that you can also have like 15, 8, 1, what else? -6. So would this be considered an arithmetic sequence? So notice, how can I get from 15 to 8? Well, I'm subtracting a 7, right? How do I get from here to here? I'm subtracting another 7. How do I get from here to here? I'm subtracting another 7. So notice that I'm subtracting a value, so this one is also arithmetic. Okay, so arithmetic sequences can either go up or they can either go down. Okay, so what we're going to try to do is we're going to see if we can come up with a formula for arithmetic sequences. Okay, so the way that we're going to do it is that you can see that you have this value here, and we're going to call it we're going to have a couple of terms. So A1 is what we're going to call the first term. D here is what we're going to call the common difference. So basically, this D value for the first sequence was actually equal to 2 because I was adding 2 to each individual term to get to the next one. For this one, D would be -7 because I was subtracting off 7 to each of them. Okay, so let's kind of try to figure out some of the or how we can come up with the formula. So remember, an is also what we're going to call the general term. So this is for any value of m. And then n here is going to be the position. So what position am I in? Am I in the first term, second term, whatever? Okay, so what is going to be the formula? So we're going to start off with a1. Okay, so that's going to be basically the first term. So how do I get a2? Well, a2 is basically you just take the first term and you add it to the common difference, which is d. Okay, how do you get the third term? Well, the third term, you get it by taking a2 and adding it to d. But do we know what a2 is? a2 is just a1 plus d. So that's just going to be a1 plus d, and then we have an extra d there. So that's going to be a1 plus 2d. All right, cool. How do we get the fourth term? Well, the fourth term is taking a3 and adding another d. Do we know what a3 is? Yeah, we just figured it out. That was just a1 plus 2d, and then you have this extra d there. So you have a1 plus 3d. Oh, do you see a difference? Or do you see a common thing? So what do you think a5 is going to be? a5 is going to be a1 plus 4d. So basically what you're seeing is that whatever the term is, you're subtracting by 1. So if I keep going to a general term, a1's going to stay there, and then this 4, or this term, is going to be n minus 1 times d. This is the formula for arithmetic sequences. So if you want to figure out a general formula for something that's arithmetic, this is the formula that you're going to be using. Okay? So d here is a common difference. A way that you can find the common difference really easily, I would just say take a2, subtract it to a1. The second term minus the first term. That will give you the common difference really easily. Okay, so let's do an example. So let's say we want to find the 18th term of the sequence. Okay, so we have 8, to -4, and so on and so forth. Okay, so in this case, let's first start off by finding the general formula. And then we can just plug in 18 afterwards. So the first thing that we're going to do, let's write down the formula. AN equals A1 plus N minus 1 times D. So in this case, let's find what D is. So D is going to be 2 minus 8. Okay, so I'm going to get 2 minus 8. That's going to give me -6. Okay, so that means that this guy is going to be the common difference. Okay, oh, by the way, I should say that this is arithmetic, just to let you know. Because if it wasn't arithmetic, we couldn't do this. Okay, so now do we know what A1 is? Yeah, we know what A1 is. That's the first term. That's just 8. So now what we're going to do is we're going to plug it in there. So AN equals 8 plus N minus 1 times D, which is -6. And all you really have to do now is let's simplify this. So let's FOIL this thing in. You're going to get 8. So this is going to give me -6n. And then a +6. So AN is going to be equal to -6n, and then 8 plus 6 is just going to give me 14. Okay, so this formula is basically the formula for this arithmetic sequence. Okay, and what you can do, you can plug in 1 in there, and you can see that 14 minus 6 is going to give me 8. Then I plug in 2, and so on and so forth. So which term do I want? I want the 18th term. So I need to plug an 18 in there. So A18 is going to be equal to -6 times 18 plus 14. So what is that going to give me? So I'm going to take -6 times 18, and I'm going to add it to 14. I'm going to get -94. So that guy is going to be that value. Okay? All right, that's the 18th term. So let's do another problem. Find n when A1 equals 5, the common difference is -3, and the nth term is -676. Okay, so now we're finding the value of n. So what term am I in when a sub n is -76? So basically what I'm doing is that, okay, we start off with A1, which is 5. And then we keep going. We subtract 3 continuously. And then we get at a certain point in n, the nth term, you get -76. So what position is that in? Okay. So the only thing that we know how to do is kind of figure out this guy. Okay, we know how to figure out the general term, which is going to be a sub n equals A1 plus n minus 1 times d. But we don't need anything else because we can use this. So I'm going to take an by itself. I know what A1 is. A1 is just going to give me 5 plus n minus 1 times d. In this case, is -3. Okay, so let me simplify this a little bit. So get 5. I'm going to FOIL this thing in. So you're going to get -3n plus 3. That's going to give me 8 minus 3n. Okay. So now notice, I know what the nth term is. That's -76 is equal to 8 minus 3n. So now I can figure out what that value of n is. So I'm going to subtract by the 8. So you're going to take -76 minus 8. That gives me -84 is equal to -3n. So now I'm going to divide it by -3. And what I'm going to get is 28. Okay, so what this means is that the term that's -76 is the 28th term. Okay, that's exactly what that means. Okay, so when you're doing problems like this, they might be asking you many different types of questions. So sometimes they don't want a particular term. Maybe they want to know what the position of that term is going to be. Okay, so let's do a problem that's a little more challenging. So let's say we want to write the formula for the arithmetic sequence. Okay, with the two given terms. So let's say we have A5 equals negative 32, and then A18 equals 85. Okay, so there's not a lot of things that they gave us here. They don't tell us what the difference is. They don't tell us what the first term is. They basically just gave us two arbitrary terms. Okay, one thing that you can do definitely is try to see from A5 to A18, from negative 32 to 85, how many times am I adding D until I get to that point? That can be a little tedious too. So, but this is what we're going to do. So we're going to start off first with A5. Okay, so we know that A5 is equal to negative 32. So let's start off with that guy. So let's plug it into the formula. AN equals A1 plus N minus 1 times D. So I know what AN, or we know what N is. N is going to be 5. So A5 equals A1 plus 5 minus 1 times D. A5 in this case happens to be negative 32. I don't know what A1 is. Okay, and this guy is just going to be 4. And then times D. Okay, there's really nothing else that I can do here. Okay, so now can I do it for the other one? So A18, which gives me 85. Okay, well, this one we're going to do the same thing. AN, whoops. So AN equals A1 plus N minus 1 times D. So we're going to plug in 18, since I know that that's the 18th term. So A1 plus 18 minus 1 times D. So we're going to have A18, which in this case gives me 85, is equal to A1 plus 17D. So notice here that what we have is a system of two equations. We have negative 32 equals A1 plus 4D. And then we have 85 is equal to A1 plus 17D. So we just have a system. So in this case, you can use matrices if you want. You don't need to use matrices. Or you can just use substitution or elimination. So I'm going to use elimination. I'm going to multiply this by a negative 1. So we're going to have a positive 32. It's going to be equal to negative A1 minus 4D. This guy's going to stay the same. 85 equals A1 plus 17D. You can see that the A1s cancel out. And I have 17 minus 4, which gives me 13D. And then here you just have 85 plus 32. And that's going to give me 117. So when I divide it by 13, you're going to get 9. So the common difference in this case is going to be 9. So basically what I'm doing is from this number, I'm just adding 9 continuously. That's what I'm doing. Okay. Can we figure out what A1 is? Yeah. So let's go ahead and plug that in. A5 equals A1 plus 17D, which is 9. So 85 equals A1. 17 times 9 gives me 153. Okay, so I'm going to take 85 and I'm going to subtract by 153. That's going to give me negative 68 equals A1. So what that means is that the real solution, A sub n, is going to be A1, which is negative 68, plus n minus 1 times d, which is 9. And I can FOIL this out. So you're going to get an equals negative 68 plus 9 minus 9. So A sub n gives me negative 68 minus 9, which gives me negative 77 plus 9n. So here is the true formula. So a little bit more involved, but you can still do it using a system of equations. And now I can figure out what any value of n is. If I wanted to know the 13th term, I can plug in 13 now. Okay, so just how we have sequences, arithmetic sequences, we also have arithmetic sums or arithmetic series. Okay, and here's what we're going to call partial sums. Okay, so basically if I have a sum of arithmetic sequences, which is what we call a series, and I wanted to add all of these together, there is a formula that I can add all of these guys up. And the formula in this case would be S sub n is equal to n over 2 a1 plus an. So this is the sum for arithmetic series and what we call partial sums. So if you wanted to know what the sum of the first 13 series are for some or sequence of arithmetic sequences are, then all you need to know is tell me how many numbers you're adding up, what the first term is, and what the last term is. That's how you find it. So let's do an example. So let's say you wanted to find the sum of the first 15 terms of the arithmetic sequence and the sequence in this case is going to be 13, 10, 7, 4, and then it continues on. Okay, so how would you do this? Well, we need to figure out a couple things. So the first thing is that we want to find the first 15 terms. Okay, so instead of adding all 15, what we're going to do is we're going to use this formula. Okay, so this is hopefully going to be a little faster. So in this case, n is going to be equal to 15 because we're going to add 15 terms. Do we know what a1 is? Yeah, we know what the a1 is. a1 is going to be equal to 13. Do we know an? Well, an is going to be a15. That I still don't know what that is. So let's figure that out. And we know how to do that by using the general formula a sub n equals a1 plus n minus 1 times t. So to figure out the 15th term, a1 is 13 plus 15 minus 1 times t. So notice what is going to be the value of t. So if I take 10 minus 13, that gives me negative 3. So the value of t is going to be negative 3. So a15 is going to be whatever the heck that is. This is going to be 13 plus, that's going to give me 14 times negative 3 is going to give me negative 29. So now that I have that, I can plug that into my formula for the sum. So we're going to have the sum of the first 15 terms is going to be equal to 15 divided by 2. a1 is 13 plus then negative 29. And then that's going to give me my answer. So what is that? So 15 over 2, 13 plus negative 29, that's going to give me negative 120. So what that means is that if I sum the first 15 terms, the sum of the first 15 terms of this sequence is going to be equal to negative 120.